Here question number 1.244 from Irodov, and in this question it is given that the ends of a thin thread is tightly wound on the axle of radius r with a Maxwell disc are attached at a horizontal bar. When the disc unwinds, the bar is released to keep the disc at the same height. The mass of the disc within the axle is equal to m, and the moment of inertia is of the arrangement relative to its axle is I. Find the tension of each thread and acceleration of the bar. So for solving this question, first of all we will consider the equilibrium condition. The condition for equilibrium. The condition for equilibrium for this case will give us the summation of all forces is equal to 0, and similarly torque will be balanced. So for equilibrium of forces, from this figure it is given that the tensions in two threads are equal and they are T, and the weight of the object or body is acting downwards. So from this diagram we can write that 2T equal to 2T is equal to mg, or we can write T, tension of the string will be mg divided by 2. So this is the tension of the string. Let this is equation number 1. Now we'll balance the torque equation. From the torque equation, as we know, total force F net into its corresponding distance, means F net into R will be equal to I alpha, where I is the moment of inertia of the system and alpha is the angular acceleration. But F net is given as 2T. This is F net. From this equation we can write 2T into R equal to I alpha, but now value of alpha is equal to A divided by R. So we can write, but from this equation we can see 2T equal to mg, so we can replace mg instead of 2T. So we can write mgr equal to Ia divided by R. Now we have to find the acceleration of the system. For the acceleration of the system, A will be mg r square divided by I. So this is our required or short acceleration of the system. So acceleration of the system will be A equal to mg r square divided by I. Or if you want to find the angular acceleration, then our alpha will be A divided by R. So that will be again equal to mg r divided by I. So this is our required equation for angular acceleration. This is angular acceleration, this is linear acceleration, and this is tension of the each string are given in equation number 1. So this is our solved question.